First talks on Lockahead, shared file performance improvements. I can't claim I know my name's on there, but really this gentleman did most of the work, is Patrick Carl of CRAY. He's a developer, software developer at CRAY that actually did all this. And I have you know that these slides contain no marketing slides whatsoever this time. Okay, the agenda, looking at the shared file problem, sequence of events that lead to that problem, a solution, usage and performance, and when it's available. There are two primary approaches when doing I/O. You have your file process, which scales very well in Lustre, and then it's also this shared file situation, which currently doesn't scale very well. Basically, with the shared file I/O, you have most HPC applications use MPIO, and they do so to try to do good shared file I/O using a technique called collective buffering. Basically, the I/O is aggregated to a set of nodes, and each of these nodes handle part of the file, and writes are sharded and non-overlapping. A good example is client 1 may be responsible for writes to blocks, say, 0, 2, and 4, and client 2 might write at blocks 1, 3, and 5, for example. Bandwidth test, well, basically in this, most of the tests are being done with one OST. And going from one, basically, when you have a situation where you're writing to a single OST and you have more than one client, that's where you start to get this contention with the logging. In this particular graph, the blue line actually is a particular type of locking used with shared file, and so is the green. The green is the standard one that uses extents. And the goal is the red lines. That's basically file per process type speed. Why it doesn't scale? Well, the I/O actually is strided and non-overlapping. You would expect it to scale. But what happens is once you start getting into having more than one client write to an OST, you start running into issues with the log manager. And so basically what happens is when you have a single OST, or this also applies even if it's private, but related to individual OSTs themselves. When two clients start doing their writes, for example, client 1 will ask for a lock to do so he can write segment 0. The lock from client 1 has to be called back when client 2 wants to write to block 1. But when he requests the lock, he gets this extent for the whole file. Then what happens is you're back to client 1 tries to write to block 2. He can't because client 2 has the lock on that particular portion of the file. So then that lock has to be called back, and this whole process continues on. So basically, when you end with multiple clients per OST, your I/O then is pretty much serialized. And because of this whole handshaking sequence, you end up with additional latency. Well, you might ask, okay, well, don't turn on the extended lock feature. Well, the end result is the actual result is the performance is actually even worse. And because you have to ask for a lock for every time you do a write, and so that original graph back here, yeah, that's what this blue line is at the bottom. That's their attempt at doing shared I/O, but not using the extents. Find one place to be. Okay, so what we proposed was this technique called Lockahead, and it basically means that through IOCTL calls that the server grants only the extents that you need, so that you're only requesting for locks for the areas that you actually do your I/O on. And part of the pros of it is it's flexible, especially if you have different I/O patterns. And the feeling was it was relatively easy to implement. Now the cons are the typical situations where the unknowns, what about files with large files? Are we going to run out of locks? We're going to have issues with locks, or how many items are we going to pull out of the lock manager, the bugs are going to pull out of it. So basically how it works is client 1 decides he wants the right to block 0. But because he knows he needs the right to block 0, 2, and 4, he actually requests the locks for those. And so, and the locks themselves are not expanded, so it doesn't expand for the length of the file. And then client 2 can come along and he requests his locks for segments 1, 3, and 5. So basically both operations are done in parallel, so there's no blocking conflicts. Well, actually, there's a technique in Lustre called group locks, but the problem with group locks is the way it's implemented. It's almost like you don't do any locks, and you get into a situation where this one shared lock is handled by all the participants in the group, and because of that, there's no notification of updates. So you can actually, if you're not careful, you can end up with data that's out of sync. So because of that, it maybe work okay in some group workloads, and sometimes it not. And in certain applications like HDF5, it doesn't work very well at all. Another way you can get around it, I guess you could do S things between every write, but then of course then you lose all your performance enhancements in your inlet. So some of the early preliminary performance results from it showed that it was pretty close, if not equal, to file for process performance, and also in cases if you were to use the group locks. It was intended to match also with the MPIO collective buffering techniques. And currently CRAY has a patch available for it, and codes do need to be rebuilt. They have to be relinked with the new MPIO library. This particular graph shows comparisons of different number of writings for both the group lock using writes and reads of the group locks and the Lockahead feature. As you can see, they're fairly close in this particular case. I think when this is pretty early, some results that were done pretty early, and the read Lockahead was a little slower than they expected. I think they've worked out some of that issues since then. Also, here's a case using HDF5, and as you can see, you got your standard locks and then the use of Lockahead. And you can see that there's quite a bit of difference in performance, and it depends on what you're doing, how big a difference there is. Like in the case of the last one with one-neck transfers, it's not quite 3 times, but it's about 2.5 times better performance. Okay. And here's a case using the group locks and the Lockahead, which you expect them to be very similar. They are. They're very close, almost identical results. And in implementing it, they basically, what Patrick did is reuse much of the asynchronous glimpse logic, and he also added a LDM, the lock manager flag that says, do not expand the locks. And currently, the code is out. It's scheduled for Lustre 2.10. But we currently have it in the CRAY release with Lustre 2.7, which happens to be in the CRAY system. It's in CLE 5.2 update 4. And it's soon to be in the CRAY Select in EO 2.0 update 22. Which I was hoping that we've had some more up-to-date performance results. We just got the new system with the latest NEO in, end of last week, and they're just getting it up and going now.